let's answer this question on the board. The molecule with the highest number of lone pair of electrons is. Now, for us to answer this question, we must first of all draw these molecules in their Lewis dot formula. After drawing that, you can now detect how many lone pairs are available in this molecule. Now, let's start with water. Now, water, the central atom for water is oxygen. And we know that oxygen is the central atom for water. And oxygen is in group 6. So since oxygen is in group 6, that means that oxygen has 6 electrons in its atom shell. So we are going to share this 6 electron revolving around this oxygen atom. So for oxygen here, we have 1 electron here. We have another one here. We have 2 here. We also have 2 here. We also have 1 here. Now, the atom of hydrogen, which has 1 electron in its atom shell, will come up to form a bond here with oxygen. So this is the bond for hydrogen. And the next hydrogen, which is second hydrogen in molecules of water, will come up here to form a bond here. Now, if you look at this, there are 2 bonds here in both sides here, and they are lone pairs of electrons here. So this is the first lone pair here, and this is the first lone. So we only have 2 lone pair in water. Now the next one is ammonia. Ammonia, the central atom is nitrogen, and nitrogen is in group 5. So we want to share these 5 electrons around the nitrogen atom. So we can share it like this: singly first, then we pair it. So if you look at this, we have 1, 2, 3, 4, 5. Nitrogen is in group 5 and 5 electrons in atom shell. So we have 3 hydrogen, which is attached to this nitrogen atom. So the hydrogen will come up here to form a bond here. Another hydrogen will come to form a bond here. Another hydrogen will come to form a bond here. And we have 3 hydrogen forming a bond here, which make up the ammonia. And if you look at this, you only have 1 lone pair of electrons. Now for the next one, which is methane. So methane, the central atom is carbon, and carbon is in group 4 element. So the first atom, the first electron will be there, second electron, third electron, and the fourth electron. So that make up the outermost shell of carbon. Now hydrogen will come up here to form a bond here. Another hydrogen will come up here to form a bond here. Another hydrogen will come up here to form a bond here. Another hydrogen will come up to form a bond here. And if you look at this, there is no lone pair of electrons. So we have 0 lone pair of electron here. Now the last one, which is carbon 4 oxide. So carbon is in group 4 elements with 4 electrons in its atom shell. And the bond that exists between carbon and oxygen in carbon 4 oxide is double bond. So that means that the 2 bond here will come up here, and another 2 bond will come up here, which make up the 4 electrons in atom shells of carbon. Then oxygen will come up with its own electron to form a bond here. Another oxygen will come up here to form a bond here, which make up the double bond for this compound. Now, if you look at the oxygen has 6 electrons in atom shell. So we're going to share this 6 electron around the oxygen. So we can fill up here with 2, fill up here with 2. So that make up the 6. You can also fill up here with the 2 and fill up here with the 2. So if you look at this, in this carbon 4 oxide, the number of lone pairs available here is 1, 2, 3, 4. So we have 4 lone pairs of electron here. So the answer to this question is carbon 4 oxide, which is the answer. Thank you.